time we want to find the smallest value of b such that the function from a restricted domain from negative infinity to b maps onto R, where f of x equals minus x to the fourth plus 2x cubed. We want to find the smallest value of b such that that function will have an inverse function. Although we're talking about inverse functions here, we're also really talking about finding the turning point of that graph. So we will define the function, a function that we want to graph later on. So menu, actions, define. We'll call it f1 of x equal to 2 times x cubed minus x to the power of 4. We want to calculate the gradient function. To do this, we'll press the template next to the book. The command that I want is already highlighted, d by dx. Type in the x, type in the function f1 of x. Alternatively, we can get it from the var command. So that will give me the gradient function, 6x squared minus 4x cubed. Alright, we want to find where the gradient is 0. So we'll go menu, algebra, solve. Solve where the gradient, that's d by dx of f1 of x, is equal to 0. We want to solve that for the x values. Two x values, x equals 0 and x equals 3 on 2. Alright, let's try to calculate the y values corresponding to those. To do that, all we have to do is evaluate the function f1 at 0. So that gives me the y value when x is 0, y is 0. Rather than type it in again, let's just press the up arrow command, and this time change the 0 to 3 on 2. This gives me the exact y value of 27 on 16. Alright, once again, we'll look at the graph of this function. So there's the graph of the function . There's the graph of the function, 2x cubed minus x to the fourth. We see it has a stationary point of inflection at 0, 0, and a maximum turning point at x equals 3 on 2, y equals 27 on 16. So if I want to restrict the domain of this function, how can I do that so that it's going to be a 1, 1 function? Well, the gradient is positive, 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 0 at the point of inflection, positive, 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 but the gradient is also 0 at the turning point. Here, the gradient is negative. So if we want to restrict the domain such that it has a 1, 1 function, then we will have to restrict it so that x is smaller than 3 on 2, the value of that y, the value of that x turning point. So, in summary, the graph has an inflection point at x equals 0, the origin, a maximum turning point at 3 on 2, 27 on 16. The function is a 1, 1 function when its domain is restricted to negative infinity to b, where b is smaller than 3 on 2.